So I wanted to comment a little bit further about this expression right here. So I talked about the fact that this was not a typo, and that if we wanted to find the estimated standard error of the I-1th estimated regression coefficient, we had to look in the ith diagonal position of a certain matrix, and that's correct. But I just wanted to be a little bit more specific about what I mean. So we're not going to talk about the standard error here, but for simplicity, we'll instead talk about the variance of beta hat. So you might recall that beta hat is just the vector with our estimated regression coefficients. So I'm just going to use 3 regression coefficients, the intercept, and then 2 other coefficients related to regressors. So beta naught hat, beta 1 hat, and beta 2 hat. And we have derived that the variance of beta hat is sigma squared times x transpose x inverse. We looked at that earlier in the slides, right here. Okay, so we actually derived this earlier. And I want to show the relationship between this variance matrix and the variance of the individual elements. So we're looking at the variance of beta hat. And we know that using matrix form, it's going to be sigma squared times x transpose x inverse. But the question is, what exactly is in this matrix at a practical level? So you're going to have, in this first position, the variance of beta naught hat. In the beginning of the second row, we're going to have the covariance between beta 1 hat and beta 1 hat. In the last row, it's going to be the covariance of beta 2 hat, and it should be beta naught hat. Beta naught hat. In the second column here, we're going to have the covariance between beta naught hat and beta 1 hat. The second diagonal element is going to be the variance of beta 1 hat. This third position here is going to be the covariance between beta 2 hat and beta 1 hat. And this last column, we're going to have the covariance of beta naught hat with beta 2 hat, covariance of beta 1 hat with beta 2 hat, and then the last one is going to be the variance of beta 2 hat. Okay, so this 3 by 3 matrix is what sigma squared times x transpose x inverse is actually computing. So then, if we wanted the variance of beta naught hat, for example, then we would look in the first diagonal element of this matrix, right? So it's going to be sigma squared times x transpose inverse. I guess this should be 1, 1, right? And so because we start counting our regression coefficients as 0 instead of 1, we're trying to find the variance or the standard error of our estimated regression coefficient, our I-1th regression coefficient, we have to look in the ith diagonal position of this matrix right here.